This is the brief on the geometric link between the sides of a parallelogram and its diagonals. So you've got a parallelogram. Ever wonder what makes its diagonals cross at a perfect 90-degree angle? Well, it all boils down to one single strict requirement, a condition we call orthogonality. First up, the key insight is actually really simple. The diagonals can only be perpendicular if and only if the two adjacent sides of the parallelogram have the exact same length. That's the fundamental, non-negotiable condition. Second, the math totally confirms this. When you use something called the dot product, which is just a vector test for perpendicularity, you can see it in action. The moment those side lengths are made equal, the result of the dot product instantly goes to zero, proving that 90-degree angle. And finally, what do we call this shape? Well, a parallelogram where the adjacent sides are equal is, by definition, a rhombus. So that means the rhombus is the only kind of parallelogram that's guaranteed to have those perfectly perpendicular diagonals. The requirement for perpendicular diagonals is strict. The adjacent sides must have equal length, and that defines the parallelogram as a rhombus.